Question 4, Part A. F and J both contains the arene functional group. Part 1. Identify the others functional group in F and J. In the F, we can see amine groups here, NH2, and carboxylic acid. Right. So therefore, in this compound F, so it has this amine and carboxylic acid. So for the J, this is quite special. You should not really put the hydroxyl. If it's a normal aliphatic alcohol, so you can mention hydroxyl, because in the A2 syllabus, when OH direct bond to the benzene ring, so this functional group we call phenol, right? So you have to put phenol, and this is the ester group, right? Part 2. State the numbers of chiral center in the molecule F and J. So for the molecule F, so what we can see is all the carbons here, they are sp2 carbon, so it cannot really form or have any chiral center. So for the compound F, so no chiral center. And for the compound J, so we try to look at the sp3 carbon. So all these carbons here, sp2, and this one sp2, so this one cannot form a chiral center. And the chiral carbon or chiral center is here, this one. So this carbon is bonded to one hydrogen and three others group, 1, 2, 3 groups. So means total 4 different groups. So this will be a chiral carbon. So this one is CH2, not chiral carbon. This one CH2, not chiral carbon. This one nope. This one also not the chiral carbon. This one also cannot be chiral carbon because bonded to two same group here. So another chiral carbon is here. So this carbon again bonded to hydrogen, one group, two group, and another group. So it's 4 different groups with this carbon. So therefore we know that molecule J it has the 2 chiral center. B. A student proposed a multi-step synthesis of F from benzene ring as shown in table 4.1. Complete table 4.1 and by providing relevant details of reagent and conditions for the step 1 to 4. And the structure of product D. Okay, so let's start with the step 1. From the benzene to the methylbenzene. So we need to use this chloromethane, CH3Cl, and the catalyst, AlCl3. So because this is the alkylation of benzene, so we need to use these two. If you want to know more about how it reacts, so let's go. For this one, the first step, okay, told you already just now, you need to use chloromethane and the catalyst. So the one chloride from the chloromethane will gains by the catalyst to form the AlCl4 negative, and the CH3 here will form a carbocation, which is the electrophile. And these carbocation ions will react with the benzene. Benzene will donate a pair of electrons to this carbocation ion, and it's formed this intermediate. Of course, this intermediate you have to put a curved and a positive charge in the ring. So you need to show the CH bond break, the arrow point into the ring, and therefore these hydrogens will remove as the hydrogen ion. So this one is the electrophilic substitution. After that, it will form the methylbenzene. So for the step 2, Step 2 is the methyl benzene that form here. So it will react with this reaction, nitration mixture, and it will form the nitrobenzene. So first, you need to know the effects of this methyl group or alkyl group. So alkyl group, you should know that is this 2,4 directing. So means whenever there is a electrophilic substitutions, so it will be just 2, 4, or 6 position. So that's the effects of these substituents. So now, if let's say we have a nitration mixture, which is a concentrated HNO3 and concentrated H2SO4, so it will form this. Okay, so this is step 2, this one. This nitric acid with sulfuric acid, it will form the nitronium ion, the NO2 positive, with these side products, HSO4 negative and H2O. The electrophile that form means the nitronium ion, okay, will react with the methyl benzene just now, and is because the substitution can happen at this position, and this position. Of course, it's better to make it this 1, 4 position, means this is the first one, 1, 2, 3, 4. So 4th position. So therefore, it will form this intermediate. So the new bonds form between the carbons here with the nitrogens to form this bonding. And after that, it will form this intermediate. So you just draw a curve and a charge positive here. CH bond break, and this one will remove as hydrogen ion, and this nitrobenzenes form. Right. So this is how to form the products. So therefore, we have this. Okay, after we use this concentrated HNO3 and concentrated H2SO4, nitration happen, and the electrophilic substitution happen at the 4th carbon here. So therefore, it will form this D. Right. So this is the first carbon. I mean, just now for the substitutions, before the substitution happen. So this is the first carbon, second carbon, third carbon, 4th carbon. Right. Okay. So this one is a 1, 4 position. For this step 3, we know that the D here will react with hot alkaline KMnO4, then the dilute H2SO4. Dilute H2SO4 is for the acidification. So when you see these reagents and the condition, so you should know that is the oxidation of alkyl benzene. Means just now the D has 1 methyl benzene here. The methyl group here will oxidize to form the COOH, this benzoic acid. So this is the oxidation of the alkyl benzene. This one you should know. After that, for step 4, the product E now is further reacts with the something. So the difference is here. Nitrobenzene now is formed phenylamine, right? So means this is the reduction reaction. So reduction means these two oxygens will get removed and 2 hydrogen added. So when oxygens removed and hydrogen added, so we know that this is a reduction. So to reduce the nitrobenzene, we just use this one, hot tin and concentrated HCl. So next part 2. In the second multi-step synthesis, the student changes the order in which the reagents and conditions are used. So it's shown in this figure 4.2. G is the major product of this synthesis. So later you have to propose the structure of the G. Okay, step 1 here, see, from the this benzene to methylbenzene, so same. Then after that, this step 2, the student used the hot alkaline KMnO4, then the dilute H2SO4. So means this methylbenzene will oxidize to form the benzoic acid. And after that, this benzoic acid will undergo nitration. You see that? This one, nitration. So means this one, it will react with the nitronium ion just now. Okay, so therefore, the first thing that you need to know is the effects of this COOH, this group. So this group is electron withdrawing groups, so it's 3,5 directing. Means when there is a electrophilic substitution, so the substitution will happen at the 3,5 position. Means this is first, second, third, right? So 3,5 position. So means the nitration means this nitronium ion, later it will react with benzene ring and it will bond to this third carbon, right? So therefore, when there is reactions, right, between this third carbon, so this is the products, means the nitro group will be at this position, 1, 2, 3, right? So the carbon. So only one positions will involve. Okay, let's say it's this one, right? So it won't be 2 nitro groups there, just one only. So the okay, now is this one. Draw the structure of G, already done. Explain why G is a major product in this synthesis rather than E. E is the product just now, which is this one. So E is actually the 1,4 position, right? Now it's 1,3 position. So actually this is not really the one that we need to focus rather than E. So you just need to mention why there is this 3,5 substitution. Okay, very easy. Actually, this one, right? So you just need to mention the COOH is electron withdrawing, so means it will withdraw an electron toward itself. It's something like this, something like this. So COOH, so it will withdraw an electron from benzene ring. Electrons from benzene ring move to this COOH, and eventually it will form this resonance structure. You no need to know how to draw this resonance structure. So the first resonance structure is this one. Okay, you can see that the positive charge is on the second carbon, and after that the electrons will shift. So shift to this, and eventually it will form this second resonance structure. So for the second resonance structure, you see that the positive charge is at this fourth carbon, and after that the electrons will move again. So it will form this electron move again to form this third resonance structure, and you can see the charge positive is at 6 carbon. So 1 means 1, 2, 3, 4, 5, 6, right? So you can see the charge positive is actually at 2, 4, 6 position. And the charge positive is actually the one that will not really welcome the electrophile, because the electrophile, let's say the nitronium is positive charge, so the electrophile will not get near to this 2, 4, 6 position. That's why we say that the COOH group actually is deactivate the benzene ring, and is deactivate at 2, 4, 6 position, like I told you just now, 2, 4, 6. And since the 2, 4, 6 is get deactivated, so which place is active now? The place that active is 3, 5. So therefore, the nitronium has no choice. It must move to the 3, 5 position, right? So therefore, it's only direct 3, 5 substitution. I hope you understand. For part C, the J reacts under suitable condition with sodium hydroxide. after acidification of the reaction mixture, compound K and L form. So this one is actually involve two reactions. So first, hydrolysis of the ester happen because it's a sodium hydroxide aqueous. So hydrolysis means the ester bond break here, and this carbonyl group will get OH, this oxygen will get H, right? So therefore it will form this part, okay, this part. Okay, this part will form, and it's something like this, right? Then the carboxylic acid will further react with the alkynes, so to form this carboxylate. And of course the phenol itself also will react because it's a weak acid, so it will form this phenoxide too, right? Then after that it need to undergo the acidification. You see that acidification means this product will react with the H plus, so the H plus will exchange with the sodium ion, and eventually it will form this K, right? So form this phenol and this carboxylic acid, right? So that's how it's happen. Part 1, give the molecular formula of L. So L is this, yeah? Since the K already know, L is actually this one, right? So it's from this hydrolysis here. So it's from this. So you just give the molecular formula. So it's 9 carbon here, and 18 hydrogen and 1 oxygen. Right. Part 2, state the two types of reactions that occur when J reacts with sodium hydroxide. So I told you already, the first step is hydrolysis of ester. Second step is the acidification, which is this acid-base reaction, or the this one, hydrolysis, acid-base. So hydrolysis, this is the first step again. So this is the first step, okay, hydrolysis. After that, this is the acid-base reaction, two-step reaction, okay, the acids with the alkaline. Okay, part D, the K also can be synthesized from the phenol. So from phenol to form this K. Now, figure 4.4 shows some reactions of phenols. So 3 reactions that involve the reaction 1 and 2 is the one that asked. The reaction 3 is actually not this condition, and or these reagents used is actually not in your syllabus. So later it will not ask, so no worry. So this is how to form, okay, sodium hydroxide followed by CO2 and H2SO4. It's alright. So now we focus on reaction 1 and reaction 2. So reaction 1 is the sodium reacts with phenol. So phenol, we know that is the alcohol. So alcohol will react with sodium to form this alkoxide and the hydrogen. So therefore phenol reacts with sodium will form sodium phenoxide and hydrogen gas. So this is how it works. Means the M that form is the sodium phenoxide. For reaction 2, excess bromine waters used. So we know that bromine will undergo these electrophilic substitutions with this phenol. So phenol it will direct, because it's the electron donating group, so it will direct 2, 4, 6 substitution. So means the bromine is the electrophile, and the substitutions in the benzene ring is happen at these 3 position. Means the bromines here will substitute the hydrogens at these 3 position, right? So therefore it will form these products. This name you should know, 2, 4, 6, okay, because this is first carbon, 2, 3, 4, 5, 6. So it's 2, 4, 6 tri bromophenol. This is a phenol. So this is a name of the compounds that form. So I hope you understand. So this is the part 1. I told you already the equation. The phenol with sodium forms sodium phenoxide and hydrogen gas. And draw the N. This is the white precipitate, the 2,4,6 tribromophenol just now. Okay, now part 3. Explain why phenol is a weaker acid than K. So K is this one, yeah? K is this. So if we compare phenol and this K, the difference is, of course, this molecule K has the carboxylic acid. So carboxylic acid is a stronger acid than the phenol. So why? You have to explain. So in K, the carbonyl means this one, the carbonyl group. In the COOH is electron withdrawing. So it will withdraw electrons towards itself, means the oxygen. And once the electrons move to the oxygen, therefore the OH bond here is easier to break because the electron density here is lesser. So it's easier to break. When this easy to break means the H plus will form more. When H plus is more means more acidic. So this is the first effect of the carbonyl group. The carbonyl group has another effect. After it's ionized, so it will form carboxylate, isn't it? Because this carbonyl group is still electron withdrawing, it will still withdraw an electron towards itself, and the electron density on this oxide, this oxygen, is actually lesser. When the electron density is lesser, therefore is less likely to bond with the H plus. So when this H plus not really likely to bond with the this oxygen, so therefore H plus the amount is more, then is more acidic. So the effects again, the effects on this COOH, right? So the carbonyl, so it has two effects on this COOH. First is weaken the OH bond. Second, we say that it stabilizes the carboxylate. So because it's withdrawn electrons toward itself, electron density on oxygens here is lesser. So we say that this carboxylate is more stable. So we say that it's stabilized. So stabilized means is let this oxygen less likely to bond with H plus. So less reactive means more stable. That's the meaning stabilized. Okay, after that, you can explain on phenoxide also. So phenoxide is less stabilized by the delocalization of lone pair in the benzene ring. So we know that phenoxide is the oxygen, the lone pair on oxygen will delocalize in the benzene ring. But this delocalization is relatively less. The effects of the stabilization is lesser, so less stabilized. The stabilization effect on this of this carboxylic acid, carboxylate ion is stronger, is better. That's why it's less reactive, more stable. This one is not really necessary you put in, as long you put this weaken OH bond and stabilize the carboxylate, then it's good. Part E. Phenol and benzene both react with nitric acid, as shown in this figure 4.5. So phenol, as you can see, when it react with the reagent, we no need to use concentrated HNO3 and H2SO4. We just need to use dilute acid. Why? because phenol is the one that able to activate the benzene ring. Means the lone pair on the oxygens can delocalize in the ring and let the benzene ring has more electrons density. Then it's more active and able to react with the electrophiles here, means the nitric acid. So therefore it no need to use the other things like concentrated H2SO4. So this is the difference between the phenol and benzene ring. You see, benzene ring itself, okay, nothing to activate it. Therefore, it needs this concentrated HNO3 and concentrated H2SO4 in order to form a more or a reactive or stronger electrophile, like this nitronium ion. Then it will react. So means this one no need to form the nitronium ion like this, so it will straight away react. That's the difference. So if you know the difference of this, then you can answer. It's most likely because of the phenol activate the ring. That's all, right? So the answer is very easy. Lone pair of the electron on oxygen is delocalized in the ring. Means this one, the lone pair on the oxygen is delocalized in the ring. So therefore, when these electrons delocalize in the benzene ring, then the electron density in benzene ring increases. Then we say that the benzene ring now is more active, and this benzene ring able to attract and react with electrophile better and faster. Okay, I hope you understand. Thank you.